Hi everyone, let's wait for 2 more minutes so that others will register and join the session. Please wait for a moment. Thank you. Welcome all of you. Welcome to this course on Docker and Kubernetes. Before going to the course, I just want to tell you, I just wanted to tell you about the course description. The course name is Docker and Kubernetes. The prerequisite, the most important thing that you should know is the prerequisite of learning a course. So for this, no tool is required to be learned. No tool, okay? Otherwise, I will put simply like no prerequisite is needed. Prerequisite, okay? No prerequisite is needed. The course duration is 45 days. You may be disappointed with the number of days. Why? Because the entire DevOps will be covered in just 1 or 1.5 months. But why this Docker and Kubernetes is taking this much time means we will be covering the topics both intensively and extensively, so that will be useful in our real time. So that's why it is little longer, because I don't want to compromise on the content. And the fee is course fee is 4,000 INR, and classes will be from Monday to Saturday. Then what we will be getting is live classes plus recordings through Google Drive plus the material. The material which you can use in your real time. So material in the sense, my Docker notes contains about 65 pages, and we will be navigating to official documentation wherever necessary. Okay, some things I cannot incorporate into this due to paucity of time or due to some relevance. So that's why I couldn't incorporate into the notes. So that's why we will be navigating to the official Docker documentation. And coming to Kubernetes also, I have my notes, which is about 100 pages. It's 93 pages here, and we will be moving to kubernetes.io documentation wherever necessary. And apart from that, we will be using public Docker container registries, private container Docker container registries. We will be installing the things in AWS cloud. All those things we will be doing as part of this. We will be using AWS to install Docker and Kubernetes wherever it is installed. That doesn't matter. For example, we have the tool called Paint. Paint you can use in Windows, you can use in your desktop Linux also. Paint is same. the command, the things, everything will be there. For example, if you install AWS CLI, whether it is Windows or Linux, same thing will be there. Whether that machine can be in AWS or that can be in Azure. Every AWS CLI command is same irrespective of the platform in which it is installed. Like that, here also we will be installing this Kubernetes in AWS. That doesn't restrict you to use this in Azure. Okay. So you don't need to worry about that. If you don't have AWS knowledge, then as far as this course is concerned, I will teach you how to create the cluster, how to install uh, this Docker and all in the EC2 service of AWS. Okay. So that is some brief things about the course. I don't want to waste much time on this. 4,000 INR for 45 days. Each session will consist of 1 to 1.25 hours or 1 hour 15 minutes. Okay, that is the thing. Classes will be from Monday to Saturday. On Sunday there won't be any class. Okay, if there is any deployment call or anything for me in my office, then 1 or 2 days in a month I may not be able to take the class on Saturday, but mostly I will be taking on the class on every day. Okay, so that is about the course, which I don't want to waste much time on. Docker and Kubernetes. When we are talking about Docker and Kubernetes, it means we are talking about the containers. What is container? Container is simply an empty box. In today's transportation sector, containers are vital for transporting the goods and material from one location to the other location through railways, roadways, waterways, or airways. Anywhere containers are used. If you are not aware of the term container, let me show you. What is container? Container is just an empty box. Container is an empty box. This is a container, as simple as that. Without container, there is no transportation and storage sector today. So in logistics, containers are very vital. Why they are adopted and why the name is given to our software industry based containers, we will understand going forward. So container is an empty box in general. Container is an empty box. So if you see here, the containers are being carried by the cargo ships somewhere. Okay, here I think it is shipping industry. The ship is not visible here, and this is the roadways. The material will be transported through the containers in the trucks, right? So this is loading and unloading of the containers from the ships. Okay, so mostly see, this is the ship where hundreds of containers are being carried. Now, before starting this lecture, I always tell about the philosophical part of the Plato. Plato, you know, ancient philosopher. Necessity is the mother of invention. Who said this? Plato. Necessity is the mother of invention. Necessity means need of the hour. Necessity means need. The requirement is called as the necessity, and it is compulsion or it is mandatory at that point of time to survive. Necessity is the mother of invention. That means whatever the mankind has invented from its beginning is because of its necessity. For example, this fire was invented. Why fire was invented? Because there was need for cooking the food, to roast the food, to roast the meat. for that fire was invented. By different means different thoughts. Agriculture was invented to meet the increasing needs of food requirements of the growing population. Computer was invented because there was a need for increasing the computation level. For that, computers were invented. Cloud was invented because of there are some drawbacks in on-prem data centers. That's why we are moving to the cloud, and the cloud infrastructure was invented. It is one of the wonder. Like that, the concept of containers was also invented because the software industry was in need of a solution to a problem. That's why there was a necessity for inventing some tool called as containers. What was that necessity? What was the requirement? What was the problem that the software industry was facing before the invention of the concept of containers? To understand that, let's go into the software development life cycle. It is called as what? SDLC. SDLC, software development life cycle. The first step in SDLC is development of the source code for the application. The application can be web application or it can be any other web application. For every application, the first step is to develop the source code, to author the source code. That will be done by a team of engineers called as developers. A team of people called as developers. It is called as dev team in our real-time projects. The dev team, for example, it may contain tens of people also depending on the scaling of the project and it's a user base and all. Depending on that, the team will change. The size of the team will change. Let's suppose that the dev team contained only one developer, and for the application to be developed, the developer has to be provided with a laptop or desktop or in general a computer. The developer has to be provided with a laptop, say for example, and that laptop generally it may be installed with what? Windows operating system. It is installed with what? Windows operating system. Windows operating system. And let's suppose that its memory is 36 GB. Its memory is can any one of you please confirm? Am I not audible? Am I audible?
You are audible.
Yeah,
Yes, you are
Ashish
audible.
was telling like he was not able to hear. Ashish, can you please rejoin? Yeah, thank you. This developer is provided with the laptop which is installed with Windows operating system and its capacity is 36 GB of memory. Keep aside the disk space and CPU. Let's suppose that the developer needs Ubuntu operating system to develop that particular application. The developer needs what? Ubuntu operating system, but he was provided with the Windows operating system, but when he was onboarded into the project requirement is such that he needs Ubuntu operating system. For that, what the software company has to do? Software company has to go to its vendor, the hardware vendor, and the company has to buy the new hardware that may be of 36 GB of memory or based on the requirement uh, it will be procured. And here what needs to be installed? Ubuntu operating system has to be installed. And let's suppose that here also it is 36 GB of memory. For the same developer, two machines are being provided, and it's a cost burden for the company, and it is resource underutilization. It is not the prudent method that the same person is provided with the two laptops. And one thing is, this is problem for this developer also, because for some tasks he has to carry this laptop. For some tasks he has to use this laptop. So both the laptops should be with the same guy. Okay, if these are the desktop thing, and the problem will come, the cooling system has to be provided, AC should be there, power supply should be there, internet connection should be there seamlessly. All these things will come into picture. By looking at the one developer, you will be thinking like this is nothing. But typically, a software company may contain thousands and lakhs of employees also. Imagine that. It's a double cost for them. To avoid this thing, there was a beautiful tool called as hypervisor. What hypervisor will enable us is, let's suppose that this is the Windows operating system that is bought initially. This is what it is, the same Windows operating system I'm taking here. This is Windows operating system and its memory is 36 GB. Now, software industry has invented a beautiful tool called as hypervisor. Hypervisor. The hypervisor technology will enable us to install guest operating system on top of the host operating system. Here, the host operating system is Windows. Now, we wanted to have Ubuntu operating system. Instead of buying the new hardware and installing Ubuntu in that, the same hardware can be used to install multiple operating system with the help of hypervisor. Even in cloud technology also, whether it can be AWS or Azure, there will be a large server will be there, and that server will be virtualized, and AWS will be using Xen hypervisor, XEN. It will use Xen hypervisor to virtualize the hardware. Now here, with the help of hypervisor, for example, VMware, what we can do is the same Ubuntu operating system can be installed in the same host. Earlier, before the invention of hypervisor, we have procured two laptops. One is installed with the Windows, another one is installed with the Ubuntu. But with the help of hypervisor, we can install multiple operating systems in the same host machine, and these operating systems are called as what? These operating systems are called as guest operating system because they are guests, and this is the host operating system. And this operating system is exactly like installing the operating system on a bare metal hardware. So whatever the operating system that is running here, the same thing and the same functions will be there in this setup also. Okay, so now let me draw this picture clearly. Now from here to here, a lot of advancement came. That is clearly visible in this illustration. Now, just to make it more clear, I will be drawing the diagram here. This is the host operating system, and here this is a guest operating system. Sorry, this is the host operating system. This is the host. Host is now it is Windows operating system, Windows OS, Windows 11 or 10, whatever it may be, and hardware requirements will be there for here. Memory is 36 GB. Now we have installed what? Hypervisor. That hypervisor will enable us to install guest operating system. Hypervisor. So now let's suppose that Ubuntu has been installed in this. We can install as many operating system as we want, as long as there is sufficient memory in the hardware. And here what we will do is we will allocate or dedicate some amount to this amount of resources to this operating system upfront. Upfront in the sense when we are launching this, when we want to launch this operating system, we have to dedicate a portion of CPU, memory, and disk space to this particular operating system. And it is as heavy as if you are installing the Ubuntu operating system in a brand new hardware. Nothing less than that. It will be having all the functions. Now, so now the developer finally got the Ubuntu operating system. Great. Now, to develop some Java application or any application, it requires installation of some dependencies. It requires installation of dependencies. Now let's name it as binaries. Okay, so for example, if you are using Jenkins as part of DevOps, Jenkins is a Java based tool. For Jenkins, Java is a dependency. For Python Flask application, Python is a dependency. Python has to be installed. So for different applications, different dependencies are there. Here, for this particular application, for this Java application, JDK is required. That I'm calling it as binaries and libraries. Now, after installing Java, the software developer will start writing the source code for this. And now let's represent that source code in the form of application. I'm naming it as application A. The source code has been written for the application A. And in real time, we will be having multiple developers and they will be pushing their code to the central repositories. Let's suppose that GitHub in our case. GitHub is one of the distributed version control system, and we have Bitbucket, we have Azure repos, and we have a lot many. So once the development of the source code is done, this particular source code, which I have represented using YAPA, will be pushed to the central repo called as GitHub in our case. Now, This application is successfully running in the developer machine. So that's why he confirmed that, yeah, it is running successfully. So he is pushing the relevant source code to the GitHub. Now the application A's source code is now saved in the GitHub. This is YAP A. It's not over. It won't be directly deployed into the production servers. One important major step will be to test this application, and that is called as quality engineering or quality assurance. The application has to be deployed in this. And please do remember that if this application wanted to be run here also, the binaries have to be installed in this machine also. This is QA machine, this is QA server. So here also the operating system should be Ubuntu. Then we need to install the binaries. Okay. Then we need to deploy the application A. Now the QA people starts testing the application. Now please remember that the application was successfully running in the dev machine. That's why they have pushed the source code to the GitHub. The same source code is deployed into the QA server as well. But the thing here is, Ranjita, this class is already being recorded by the institute people. Okay, they will be providing it to you through the mail. Okay. Now, the application is deployed in the QA server, but the same application which was running successfully in the dev machine is failed to run in the QA. That is failed to run in the QA machine. What can be the reasons? And here firefight will happen between the dev team and QA team. There is a firefight. QA people will tell that the application is failing here. The testers are being failed. Dev people will show that the application is successfully running in their machine. So there is a fight happening between the dev and QA. This is generally referred as firefight in the DevOps culture. What was the reason? The same application is deployed here. What is the reason for the application to be failed in QA? The reasons can be, one is in terms of operating system. Here Ubuntu operating system is there. Here also Ubuntu operating system is there. Then what's the problem here? Because of the version issues. Here it may be Ubuntu X, it may be Ubuntu Y. That means here it may be Ubuntu 20 or it may be Ubuntu 22. Because of that operating system difference, that may be the reason for the application failure in the QA environment. Let's try to manage this. What we thought is that it is because of the operating system version difference, the application failed to run in QA. Let's suppose that in dev it is 20.x. Now let's suppose that we are also installing the same thing here. Earlier it is different version, but after knowing that the application is failing in QA, what we thought is changing the operating system may solve our problem. So for that, what we have done is we have installed the same version as that of the dev version. So here Ubuntu 20.x is installed. Now, even though we have made the change, still the application is failing. Why? Because of the version differences or some missing of the binaries. Here, a single application may require 5 to 6 dependencies also. And here, the 5 to 6 dependencies may not be installed. Even if it is installed, even if they are installed, we may be installing different versions of the binaries than that of the dev ones. For example, here Java 8 may be installed and that was developed. But here Java 11 may be installed. Because of that binaries issue, the application may be failed here. All these challenges are there in this kind of environment. Now, imagine a situation, imagine a situation where application along with its binaries are also carried. Here, the thing is, application along with its binaries are also packed and the same are stored in some central server. The same box which contains the application along with its dependencies. Imagine this situation. So I'm copying that. Now this application along with its binaries are stored in some central server and the same things or the same box is deployed in the QA environment now. The same is now deployed in the QA environment. Now see, an application may require about 5 to 10 dependencies, and because of the version issues, the application may be failing in the earlier setup. But with this concept of boxing, where the application along with its binaries are packed or packaged into a box, and the same box is being shipped or carried or stored in the central servers, and the same box is deployed everywhere wherever you want. Now here the operating system issue will be eliminated because we will be installing a tool. Okay, leave it. But coming to this 5 to 6 dependencies, see 5 to 10 dependencies, that problem is now overcome. Why that is overcome? Because the same application along with the same binaries which are used to develop this application, the same things are being saved to the central server and the same are being deployed without any disturbance. We don't need to install these binaries again here. The same binaries are borrowed. The same binaries are being copied from the dev machine directly to the QA machine. And if this is successfully working in the dev machine, it should work successfully in the QA machine also. And the QA will start validating it. They will be performing all types of tests. Once approved, the same thing, the same application will be deployed into the production servers. This is production server. Here, what will be deployed? The same box, the same application, and the same binaries are there. So if it is successfully running in the dev machine, it will be successfully running in the QA machine. Once the QA is validating it, once it is approved, the same will be deployed in the production server without any conflict. This kind of setup is called as containerization. Why the term containerization? I said containers are empty boxes. Here also the containers are boxes where application and binaries will be packed together. and the same boxes are being shaped. They are being shaped from one environment to the other through some central servers. Okay, how beautiful it is, friends. How beautiful it is. See how beautiful it is. So this is called as what? Containerization. Now, how this containerization works? Let me tell you that by going to the analogy of shipping industry in ancient time to the shipping industry in modern times. Now here, let's suppose that in ancient times, the shipping industry was very famous because the route to India was invented by the Vasco da Gama and others tried to come to India through sea route only. So the ships are very important those days, boats and ships. Now let's suppose that this is a ship owned by a ship owner. Let's imagine that this is a ship, this is a ship and a person owns this. Let's name the person owner itself. Let's suppose that there is a customer. There is a customer and customer has about about uh, 40 tons of fish and let's not but let's make it 50 tons 50, 50 tons of fish and 30 tons of raw material tons of raw material. Okay, and this customer comes to this ship owner and tells that tells to this owner that he wanted to transport 50 tons of fish and 30 tons of raw material from one location to the other location of the world. Let's suppose that from Tamil Nadu coast to from Chennai port to the Sri Lanka uh, that ports. Okay, so if that is the case, this person comes to this owner and tells the requirement and he will be charging for that. And he will specify the how much time it will take, how much it will cost, and what is the risk involved over the seas, and all those things will be mentioned to the customer. Now, how this fish and this thing will be put. So in ancient days, the fish will be put like this. Okay, so this is about 50 tons of fish, 50 tons of fish, and let's suppose that the raw material is this one. This is 30 tons of raw material. So they will be put like this. What happens in this scenario? When the ship is in transit, there is a possibility that the fish will be mixing up with the raw material. And before that, I forgot to tell one thing. Fish requires what? Ice. It requires cold storage. And raw material requires dry storage. Now they will be separated with some gap, but during transit, what happens? There is always a possibility for the mixing up of raw material and the fish. If this is the case, what happens? Both the fish and raw material will spoil, right? So in order to avoid this spoilage, in order to avoid this mixing up, the shipping industry came up with the concept of containers. What is container? Container is an empty box. They have made empty boxes of equal size of equal size Okay, the equal size. Now fish requires what? Fish requires cold storage. So they will be putting the ice in this and ice in this also, and they will be putting the fish in these boxes. Fish we have represented with this arrow. So let's use the same thing. Unfortunately, my mouse is not working, so I'm using the touchpad only. Okay, this. Let's suppose that this is the fish, and raw material will be put inside the other boxes like this. And raw material requires cold storage. We don't need to use any ice or anything. Okay, this is the raw material. Now let's keep this aside. Let me minimize it. So I have put that aside for time being. Now let's have the same shape in this way. Okay. So now with this container technology, what they have done, they have created they made the empty boxes and they have arranged the boxes in this way, in this way, in the shape. This way. Let's suppose that this is 50 tons of fish, 30 tons of raw material. Okay. So I don't want to waste time drawing all those things again. So this is the thing. If you observe from here to here, the difference is even if the transportation is taking too long, it may be hours or days also, there is no possibility of mixing of fish with the raw material. And even the fish in one box won't be mixing with the other box, and the fish is completely isolated from the raw material. This is one important point. Fish is isolated from the raw material because they were containerized. They were containerized means they were put inside a separate box which is completely closed from the other box. There is no interaction between them. They are completely isolated in some terms. And while they are isolated, at the same time, all the fish and the raw material is using the system resources, that is ship. They are being carried by the same ship. They are sharing the same ship. They are sharing the same system resources, but at the same time, they are isolated. That means they are isolated in the matters in which they have to be isolated for safety. At the same time, they are sharing the same resources. Now, what is its relevance in the software industry? If you remember the diagram that I have drawn here, the dependency will be the ice. The ice you can imagine as the dependencies. For example, if the fish is Java application, for example, if the fish is Jenkins application and the requirement for Jenkins is Java, this ice you can think of as Java. So this application is running in its own box with its own dependencies. This application is running in its own box and there is no process interference. There is no conflict. And at the same time, and this Jenkins application which requires one version and this Jenkins application which requires another version, the same can be run in the same system. For example, let's suppose that you have a Java application that is called application A, which requires Java 8. Yes, you can install the Java 8 and you can run that application in this box. And if you want to have another application which requires Java 11, that can also be run within the same machine using the concept of containers. Here, one application which requires Java 8 is running. Here, one application which requires Java 11 applications are running. So within the same system, two different versions are being run and the two applications are successfully running in complete isolation. At the same time, they are utilizing the same underlying operating, uh, same underlying resources. This is the shipping industry and it is relevant, its relevance to the container. Now, I said that we have the hypervisor, for example, Hyper-V, to install the multiple operating systems to run multiple applications. But what is the advantage of this container? Okay, so I will take you to that diagram in my notes and I will explain. You may not be getting the question itself. That's fine. I will take you to the notes. So here, see, this is infrastructure, this is host operating system kernel, this is hypervisor. What we have done, we are installing the multiple operating systems here. This is Ubuntu operating system of version 20. This is Ubuntu operating system of version 22. This may be CentOS or anything. So different operating system can be installed as guest operating system in the same host. This first image I'm talking about. Okay. But in the concept of containers also, we will be using a tool called Docker. Docker is a containerization platform. Here we are installing the running the virtual machines like that of these virtual machines. But what is the advantage from here to here? Here, as we discussed, if this is the case, we can't bundle the libraries along with the application. Okay, so but coming to this container world, the application along with its libraries can be packed together. Okay, that is one advantage. Here only application A can be transported through the servers, through the central server. But here, not just the application, along with its libraries will be packaged into a box called as container, and the same can be carried from the one location to another location with the safety, and the same libraries will be installed in the target system also. And another important thing here is this operating system, this virtual machine is as heavy as if you are installing the operating system in a brand new hardware. What does it mean? For example, let's suppose that we have the hardware, we are not using the hypervisor, and we want to install Ubuntu. For that, we need to download what? Ubuntu uh, iOS file has to be downloaded, which will be about 2.5 to 2.5 GB in size. If we download this ISO file, it will be about 2.3 GB in size. Now, so that 2.3 GB in size of operating system file has to be executed, and that will become the operating system for us. And where the 2.5 GB has to be consumed, that will be consumed from the our this hardware only. Okay, so that means to install the operating system itself, it requires a lot of memory and only few amount of resources will be left to application A, and majority of the system resources are going for just installation of this operating system, this hypervisor, and installation of this heavy operating system here. But coming to containers, here we have eliminated the need for installing the full-fledged operating system. See here, if you see from here to here, what's the difference? Here operating system is installed, but here operating system is not installed. But still we are going to have a virtual machine kind of thing. If the operating system is not installed, how this virtual machine will run? That's a good question. In the concept of containers, in the world of containers, the containers will be utilizing the underlying operating system kernel. That means if it is Ubuntu operating system and if we want to launch Ubuntu containers, these containers will be utilizing the Ubuntu operating system kernel which is there in the host. Okay, but here operating system, every virtual machine will be having its own operating system, and that will make the virtual machine as heavy. If we want to launch this operating system, it takes about 30 to 40 minutes. But to launch the containers, it takes no time. Within a second, we can launch this application in a container. I will show you practically. Theoretically, you may not be understanding, but I will show you clearly how fast the container can be launched. And here the container will be using the underlying operating system kernel, and in this case it will be having its own operating system. And one more thing from here is, when we are installing this guest operating system, we have to dedicate the system resources upfront to this machine. That means, let's suppose that if the system resources are about 36 GB of memory, and if we want to install this, it will ask how much memory you want to allocate for that machine. That has to be put upfront. For example, let's suppose that we are dedicating about 8 GB of memory to this virtual machine, and that 8 GB will be dedicated for that, and that won't be utilized by the other operating systems because that is dedicated by this. If the application A is utilizing, that is fine. If the application A is not utilizing, if it is only utilizing 2 GB and remaining will be wasted, that will be just kept idle. It is waste of resources. But coming to container, there is we don't need to dedicate the resources to the container upfront. Instead, the containers will be utilizing the system resources as and when required. There is no tight restriction that we should allocate the resources to this virtual machine upfront. Okay, so that is one of the importance of the container. One is the containers can be speedily booted up, but whereas these virtual machines will take about 30 to 40 minutes of time, but in case of containers, it won't take more than minute. It will be in seconds only. That is the advantage. So here I will clearly explain you these things tomorrow as well. Practically, we will show. I will show everything we will be doing practical only. Okay. So Docker and Kubernetes. Docker is a containerization tool. Containerization tool. What is containerization? The process of making containers. Okay, making containers is called as what? Containerization. Containerization. What is container? Container is an empty box in general, but to be specific, Here, container is running instance of an image. Another concept called image. Which image it is? Docker image. Docker image is nothing but the Docker image is nothing but the application A along with its libraries. Application along with its libraries is called as what? Docker image. And you may be getting some doubt like that just now you told like this is a container and now you are talking like this is an image. What's the difference between the two? Generally, when the when the application and its libraries are in a file packaged together, that is called image. When we execute that image, that is called as container. That means when this is executed, when it comes into running state, then that is called as what? Container. Container is nothing but what? Running instance of an image. Which image? Docker image in our case. And I will tell you this thing tomorrow again. What is this image? What is container? How to launch container? How to install container runtime? All these things we will see tomorrow. That's all for today, friends. I just want to brief you about the course. It is Docker and Kubernetes. Docker is a containerization tool. Kubernetes is a container orchestration tool. What is orchestration? That we will see going forward. And the duration is 45 days, Monday to Saturday. Monday to Saturday. You will be getting live
Sir, what is the time?
classes. Yeah, I will mention. Oh, sorry, I forgot to mention the time. So time will be 9 p.m. to 9 p.m. to 10 p.m. IST, friends. This is Indian Standard Time. Uh, then course fee is what you will be getting live classes plus recordings through Google Drive plus my entire notes will be shared to you through Google Drive. Then course fee is 4,000 INR. Okay, so everything will be real time only. We will be doing the practical things in every class. Tomorrow we will start Docker and we will be learning the commands, the Docker file and everything. And this is very important for developers and DevOps engineers. Syllabus, they have put that in the website, friends. Please go through it. Okay. You'll
What's the
get to know
split
it.
between Docker and Kubernetes in terms of classes?
Uh, in terms of classes means what?
I mean, is it like 10 classes of Docker and then 30?
Yeah, about 15 classes of Docker, about 25 classes of Kubernetes,
And
20
will
to
we
25.
be able to write any of the Kubernetes exams after this?
Yes, yeah, Kubernetes exam you can write. Kubernetes exam is a practical one, and whatever I tell in the class, if you practice, then you will be able to crack that exam also. You need practice for it.
Which one? The developer?
Both. Only slight difference will be there between CKND and that thing. Kubernetes certified Kubernetes administration and developer. Okay.
Yeah.
So administrator course it will be suitable. Developers will also be same syllabus will be there more or less.
Okay. So you're saying
Yeah.
this course is more geared towards administration.
Yeah.
Okay.
Yeah.
So,
Sir, in
sir,
Kubernetes, are you going to discuss about Helm charts and all everything? Or
Helm, I will just introduce you to the concept of Helm, friends. Helm is a another course like a Kubernetes. It takes about 1 month to teach Helm. Just I will take 2 or 3 classes. Okay, we can't
uh,
cover everything in this. Yeah,
okay, and are you going to tell by keeping in the mind of Java developers, sir? Or,
yeah. For every developer, it will be same. For every developer, they will be writing the Docker file. Okay, we will discuss about the Docker files of Java, Python, Node.js, and all. And Kubernetes. For developers and for DevOps engineers, it's most important, and for developers also, it is required to learn it. It's more like DevOps perspective. DevOps perspective means it's more than the developer's perspective. Okay.
So, sir, yeah, I'm an AWS data engineer, and I don't do any deployments. So, how this course will be useful to me?
If you don't do deployment, that's not useful, but you will be doing in the future, right? Every
I mean,
time
we
you
do,
won't
we
be
create CI/CD pipelines, so to do the deployments, but we don't do it like, in AWS also we do like code commit and stuff. I just wanted to understand, like, I know Docker, a lot of software engineers in my company use it, but I want to know how it will be useful to me. I'm trying to enhance my skill.
So you are from DevOps means it is required. Even for
Okay.
developers also it is required, because today the responsibility to Dockerize, to containerize an application, that means to write a Docker file, is the responsibility of the developers only. Why it is the responsibility of the developers, you will be understand going forward. Why?
Okay.
Because for different technology, the Docker file will be different. That means the commands will be known by the developers only. DevOps engineers may not be knowing all the Java commands, right? So that's the reason today the developers is the responsibility to write the Docker file.
Okay, so you're saying even though I'm a data engineer, when I develop my code, I'll be
Yeah.
creating that image with all the app and
Yes.
what all
Yes.
the binaries, and then providing it to DevOps engineer to deploy.
Yeah. For example, you are telling that you are an AWS engineer. AWS, we have Kubernetes service, we have content registry service, right? So how
Correct.
the contents will be pushed. So for that, you need to understand a part of this course, like how to create private content registries, how to push our content images to there, how to utilize them. All those things are required.
Okay, sir. Thank you so much.
Yeah. It is
Sir,
useful for everyone. Yeah.
are you provide an EKS, AWS EKS?
Yeah. EKS only.
You can teach here.
Yeah, I will teach how to create EKS from scratch. I will teach right from the creating the roles.
Yeah. Thank you.
Hello, sir. I have one question. Hello.
Yeah.
All types of we are complete here as a development and ingress. All those things we have completed with the demo.
Yes. Demo.
Means like implemented code like this.
Yes. We will be doing the things practically.
Okay.
Okay.
Sir, one question. So this both will be using Azure or Amazon cloud?
We will be using Amazon, but wherever it may be, whatever it may be, the same thing will be there in the Azure also. Okay.
Because of
But
in current situation, we are using Azure in our prospective.
in Azure, just to you need you will be using 2 or 3 steps to create the cluster in Azure. You have Azure Kubernetes service AKS. Just you will create the cluster there, and you will be adding your nodes. After that, everything will be same. Every single Kubernetes command is same irrespective of the cloud. Okay. So for example, let's suppose that I wanted to have Ubuntu operating system, whether it is in VMware or whether it is in Azure or AWS, every command will be same regarding Ubuntu, right?
Yes.
So like that, wherever you are installing Kubernetes, that doesn't matter, everything will be same. Okay, here we will be learning how to install it in EKS and creating the cluster in Azure much easier than the creation of a cluster in AWS. Yeah. Okay, friends.
Sir, the course
Please.
includes like monitoring tools.
Monitoring tool, how it will be included in Docker and Kubernetes?
Like
Because the
Prometheus,
monitor.
like
No. I will just tell you how to deploy the Prometheus and Grafana. I will just configure it. But Prometheus and Grafana itself will take 1.5 month to teach. Okay, but I will introduce you to them. I will also tell you how to deploy them in our Kubernetes cluster. That Helm and this thing.
Sure.
Okay, boy. Okay,
Thanks.
friends. Thank you. Bye. Thank you all. Let's meet tomorrow at the same time.